Very good morning, student. Let me start today class. Conservation of energy from your fourth lesson. Physics fourth lesson, 12th standard fourth lesson. The topic is conservation of energy. So what is the statement of conservation of energy? Already we learned in the lower section. What is the statement of conservation of energy means? Energy neither be created nor be destroyed. So the energy is converted from one form to the another form. So once again repeat the concept of conservation of energy. Energy neither be created nor be destroyed. Energy is converted from one form to the another form. Here, according to the Lenz law, the truth of Lenz law can be established on the basis of the law of conservation of energy. The explanation is as follows. According to Lenz law, when a magnet is moved either towards or away from the coil, the induced current produced opposes its motion. As a result, there will always be a resisting force on the moving magnet. So, induced current produces the opposite its motion. As a result, what result? There will always be a resisting force on the moving magnet. Work has to be done by some external agency to move the magnet against this resisting force. Here, the mechanical energy of the moving magnet is converted into the electrical energy. So, please note it down. This point is very important for your objective type question also. The mechanical energy of the moving magnet is converted into the electrical energy, which in turn gets converted into joule heat in the coil. That is, energy is converted from one form to another form. So, energy is converted from one form to another form is nothing but conservation of energy. So, the next important point is, on contrary to Lenz law, let us assume that the induced current helps the cause responsible for its protection. So, the cause responsible for its protection. Now, when we push the magnet little bit towards the coil, what happened? The induced current helps the movement of the magnet towards the coil. Then the magnet starts moving towards the coil without any expense of energy. This then becomes a perpetual motion machine. In practice, no such machine is possible. Therefore, the assumption that the induced current helps the cause is wrong. The Lenz law is an excellent example of conservation of energy. The next topic is very important. Two more question. Please note it down. Fleming's right-hand rule. Already we have learned in the lower section. Fleming's right-hand rule. What is the statement of Fleming right-hand rules? Here, stretch your right hand 3 fingers mutually perpendicular in the direction. The forefinger represent direction of field, or index finger. Index finger, it is indicate direction of the field. The next, thumb finger is indicate direction of motion of the conductor. Then the last order is middle finger, it is indicate direction of current. So, when a conductor moves in a magnetic field, the direction of motion of the conductor, the field and the induced current are given by Fleming's right-hand rule and is as follows. So what is the statement of right-hand rule? The thumb, index finger and middle finger of right hand are stretched out in mutually perpendicular direction. If the index finger points the direction of the magnetic field and the thumb indicates the direction of motion of the conductor, then the middle finger will indicate the direction of the induced current. Fleming's right-hand rule is also known as generator rule. Please note it down. Fleming's right-hand rule is also known as generator's rule. The next topic is motional EMF from Lorentz force. This is the important 3-mark question from your 4th lesson. Please note it down. Motional EMF from Lorentz force. Consider a straight conducting rod. Here this is the straight conducting rod AB of length L in a uniform magnetic field. This cross line indicate uniform magnetic field acting inward direction of the plane of the paper. So uniform magnetic field B vector which is directed perpendicular to the plane of the paper in figure 4.9. The length of the rod here is normal to the magnetic field. Normal means perpendicular to the magnetic field. Let the rod moves with a constant velocity towards the right hand side. The rod which is moved towards to the right hand side in a constant velocity. What happened when the rod moves? Free electrons present in it also moves with same velocity. So when the rod moves, the free electrons present in it also moves with the same velocity v vector in b vector. As a result, Lorentz force acting on the free electron in the direction from B to A and is given by the relation. Already we know the formula for the Lorentz force, magnetic force. FB vector is equal to minus E into V vector cross B vector. Then the action of this Lorentz force is to be accumulated the free electrons at the end A. This accumulation of free electrons produces the potential difference across the rod, which in turn establishes an electric field E vector directed along BA. Due to the electric field E vector, the Coulomb's force, because of free electrons moving in this rod means, which gives the Coulomb's force. Coulomb force starts acting on the free electrons along AB and is given by FV vector is equal to minus E into capital E vector. This is the first lesson, electrostatic lesson. Already we know this formula. FE vector is equal to minus E into capital E vector. So the magnitude of the electric field E vector keeps on increasing as long as accumulation of free electrons at the end A continues. The force FE vector also increases until equilibrium is reached. At equilibrium, the magnetic Lorentz force FB vector and the Coulomb force FE vector balance each other and no further accumulation of free electrons at the end A takes place. That is, modulus of FB vector is equal to modulus of FE vector. What is the value of FB vector? Minus E here. This is minus E into V cross B vector. So what is the value of FE vector? Minus E into capital E vector. Just substituting these two values, we obtained modulus of minus E into V vector cross B vector is equal to modulus of minus E into capital E vector. So when we remove this vector notation, we can multiply the direction. We can mention the direction. So that is the sin theta direction. Here theta is nothing but 90 degree because the magnetic field and the rod, moving of rod in the perpendicular direction. So theta value is 90 degree. So sin 90 degree is nothing but 1. So VB into 1 is equal to E. That means VB is equal to E, capital E. The potential difference between the two ends of the rod is V is equal to two ends of the rod is V into L. Sorry, E into L. V is equal to, V means potential difference, E into length of the rod. So V is equal to EL. So already we know the formula for the value of the E. E is nothing but VB. Just substituting the value of E, E can be replaced as VB. V is equal to VB into L. Then thus the Lorentz force on the free electrons is responsible to maintain this potential difference and hence produces EMF. Hence produces EMF. Epsilon is equal to B into LB. Here VBL can be written as BLB. So epsilon is equal to BLB. As this EMF is produced due to the movement of the rod, it is often called as motional EMF. This EMF is called as a motional EMF because this rod moving in the uniform magnetic field. This motion which is gives the EMF. That is why we called motional EMF. So the EMF produced by motion of the rod. EMF produced by the motion of the rod in the uniform magnetic field. That is why this EMF is called motional EMF. If the end A and B are connected by an external circuit of total resistance capital R, then the current, what is the formula for the current according to the Ohm's law? I is equal to V by R. Here V is representing epsilon, epsilon divided by R. So epsilon divided by R, epsilon is nothing but BLV. Epsilon, the value of epsilon is nothing but BLV. Just substituting the value of epsilon. Epsilon can be written as BLV divided by R. Flows in it. The direction of the current is found from right hand thumb rule. So this is the important 3-mark question. The next topic is very important 5-mark question. Motional EMF from Faraday's law and energy conservation. Motional EMF from Faraday's law and energy conservation. So here let me consider the rectangular conducting loop of width L. Here this is the width L in a uniform magnetic field B vector which is perpendicular to the plane of the loop and is directed inwards. A part of the loop here, this part of the loop is in the magnetic field while the remaining part is outside the magnetic field. So one part of the rectangular loop is placed in the magnetic field. The remaining part is placed in the outside of the magnetic field. What happens? When a loop is pulled with a constant velocity to the right, the area of the portion of the loop within the magnetic field will decrease. Thus, flux linked with the loop will also decreases. According to the Faraday's law, electric current is induced in the loop which flows in a direction so as to opposes the pull of the loop. So let x be the length of the loop. Here x be the length of the loop which is still within the magnetic field. Then its area is Lx. That means area of the rectangle is nothing but length into breadth. Here length is nothing but L, breadth is nothing but x. So that is why area is Lx. The magnetic flux linked with the loop is, already we know the formula, phi b is equal to integration of b vector dot dA vector. So this form can be written as BA cos theta. BA cos theta. That means phi b is equal to BA cos theta. Here theta is nothing but 0 degree. Cos 0 degree is equal to 1. Just substituting the value of cos 0 degree. the equation can be written as phi b is equal to B into A. BA means magnetic field and area of the rectangular loop A, capital A. So B into A, phi B is equal to BA. What is the value of area of the loop? Is nothing but Lx. So just subtracting the area of the loop Lx, we obtained phi B is equal to B into Lx. Phi B is equal to B into Lx. As this magnetic flux decreases due to the movement of the loop, the magnitude of the induced EMF is given by. So already we know the formula of the induced EMF formula. Epsilon is equal to d phi b divided by dt. Here what is the value of phi b? Phi b is nothing but b into Lx. Just substituting the value of phi b, we obtain the next step d by dt into b Lx. Here the magnetic field and the width of the rectangular loop L should be constant, or both are constant. So only the x value only changes. That is why BL into dx by dt. So equation can be written as epsilon is equal to BL into dx by dt. Here epsilon is equal to dx by dt is nothing but velocity. Already we know the formula for the velocity. Velocity v is equal to dx by dt. That means rate of change of displacement. Here the rectangular loop move towards to the right hand side, means the displacement should be changes. So that is why the rate of change of displacement, it is represent dx by dt. That is why can be written as v. So epsilon is equal to bl into v, where v is equal to dx by dt is the velocity of the loop. This EMF is known as motional EMF because the rectangular loop moving along the right hand side in the uniform magnetic field, it produces the EMF. That is why this EMF is called motional EMF. That means EMF produced by the motional rectangular loop, that is why it is called motional EMF, since it is produced due to the movement of the loop in the magnetic field. From Lenz's law, from the Lenz's law, it is found that the induced current flows in clockwise. The induced current flows in clockwise direction. If capital R is the resistance of the loop, capital R is the resistance of the loop, then the induced current is given by. Then the induced current is given by. Already we know the formula for the current from the Ohm's law. I is equal to V by R. Here I is equal to epsilon by R. Epsilon is nothing but BLV. Just substitute the value of epsilon. We obtain I is equal to BLV divided by capital R. The next concept is energy conservation. Energy conservation. In order to move the loop with a constant velocity v vector, a constant force that is equal and opposite to the magnetic force must be applied. Therefore, mechanical work is done to move the loop. Then the rate of doing work or power is. So what is the statement of power? What is the definition of power? Power is nothing but rate of doing electric work. That means rate of doing work is nothing but power. So here what is the formula for power? Power P is equal to F vector dot V vector. So when we remove the vector notation, we can mention the direction. Fe cos theta, Fv cos theta. Here theta is nothing but 0 degree. What happens? Cos 0 degree is nothing but 1. So the equation can be written as P is equal to Fv into 1 Fv. So P is equal to Fv. Now let us find the magnetic force acting on the loop due to its movement in the magnetic field. Let three deflecting forces F1 vector, F2 vector and F3 vector, here F1 vector, F2 vector and F3 vector acting in each side of the rectangular loop. Three deflecting force F vector and F2 vector and F3 vector be acting on the 3 segment of the loop. The general equation of such deflection force is given by, here general equation, deflection force is nothing but IL vector cross B vector. Here F2 vector and F3 vector acting are equal in magnitude and opposite in direction. So cancel to each other. So F2 and F3 are equal in magnitude but acting in a opposite direction. That is why cancel to each other. Here F1 force alone acts on the left segment of the loop in the direction of So what is the formula for the F1? F1 is nothing but IL vector cross B vector. So when we remove the vector notation, we can mention the direction. So F is equal to IL B sin theta. Here rectangular loop, movement of rectangular loop and the uniform magnetic field perpendicular to the each other. So the theta value is 90 degree. So sin 90 degree is nothing but 1. So the value of force F1 is equal to ILB. ILB. The applied force here, this is the applied force F vector must be equal to F1 in order to just move the loop with a constant velocity. But the F vector is opposite to the F1 vector. So F1 is equal to minus of F1 vector. Since F vector and F1 vector are in opposite direction. So consider only the magnitude. What is the magnitude of F vector? ILB. Here F is equal to F1. Both are equal. Is equal to IL into B. So substituting for I from equation 4.10. What is the value of I? I is nothing but BLB divided by R. Just substituting this value through this equation we obtain F is equal to I is nothing but BLB divided by R into L into B. Here L into L, L square, B into B, B square. B square into L square into V divided by capital R. F is equal to B square L square V divided by capital R. From equation 4.11, the rate at which the mechanical work is done to pull the loop from the magnetic field or power is given by. So what is the formula for the power? Power P is equal to force into velocity. So F into V. What is the value of F? B square L square V divided by R. Just substituting this value, we obtain B square L square V divided by R into V. So V into V, V square. So B square L square V square divided by capital R. This is the power formula. This is very, very important formula for your 3-mark problem. When the induced current flows in the loop, Joule heating takes place. The rate at which the thermal energy is dissipated in the loop or power dissipated is power P is equal to another one formula based on the heat. Power is equal to I square R. What is the value of I? BLB divided by R, the whole square into R. So B square L square V square divided by capital R square into R. So 1 R cancel, remaining term P is equal to B square L square divided by V square divided by capital R. This equation is exactly same as the 4.3 equation. This is 1.3 equation. P is equal to B square L square V square divided by R. So is exactly same as the equation on 4.13. Thus the mechanical work done in moving the loop appears as thermal energy in the loop. Once again repeat, mechanical work done in moving the loop appears as thermal energy in the loop. So this is a very, very important 5-mark question. Please listen carefully throughout the video. So motional EMF from Faraday's law and energy conservation. So very, very important topic. Thank you.